Do you want to host, AJ, or do you want me to host then?
You go ahead and take it, Joe.
Why, thank you.
This episode is sponsored by Front-End Masters. They have a terrific lineup of live courses you can attend either online or in person. They also have a terrific backlog of courses you can watch, including JavaScript The Good Parts, Build Web Applications with Node.js, AngularJS in Depth, and Advanced JavaScript. You can go check them out at frontendmasters.com. This episode is sponsored by Hired.com. Every week on Hired, they run an auction where over 1,000 tech companies in San Francisco, New York, and LA bid on JavaScript developers, providing them with salary and equity up front. The average JavaScript developer gets an average of 5 to 15 introductory offers and an average salary of $130,000 a year. Users can either accept an offer and go right into interviewing with the company or deny them without any continuing obligations. It's totally free for users, and when you're hired, they give you a $2,000 bonus as a thank you for using them. But if you use the JavaScript Jabber link, you'll get a $4,000 bonus instead. Finally, if you're not looking for a job but know someone who is, you can refer them to Hired and get a $1,337 bonus if they accept the job. Go sign up at hired.com/JavaScriptJabber. This episode is sponsored by DigitalOcean. DigitalOcean is the provider I use to host all of my creations. All the shows are hosted there, along with any other projects I come up with. Their user interface is simple and easy to use, their support is excellent, and their VPSs are backed on solid-state drives and are fast and responsive. Check them out at DigitalOcean.com. If you use the code JavaScriptJabber, you'll get a $10 credit.
Hello, everybody, and welcome to episode 188 of the JavaScript Jabber Show. Today on our panel, we have AJ O'Neill.
Yo, 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 coming at you live from the place that always rains.
Where's that?
I'm still in Oregon. I'll be back in Utah next week.
We also have Dave Smith.
Hey, yo.
Jameson Dance.
Hello.
And last but certainly not least, Aimee Knight.
Hello.
And I'm Joe Eames. I'll be your host for today. Chuck is not with us today. Hopefully he'll be with us next week. And we have as our very special guest, one of my absolute favorite people, Elijah Manor.
Thank you. From Tennessee.
Elijah, do you want to take a quick minute? I know that we're going to be talking today about code smells, but do you want to take a quick minute first and just kind of give us a bit of your background and bio?
Sure. Yeah, I've been developing for quite a while. I started doing Microsoft stuff back when I first developed, and then more and more I really like to be very focused in what I do. So I kind of focused on the front end of the .NET stack. And then when MVC came out, I just started doing more JavaScript, more heavy JavaScript. Actually, got heavy into jQuery because that was kind of the thing. And kind of met a lot of the jQuery core contributors and actually briefly co-hosted the jQuery podcast for a while. Stepped back and then became just a full-on just front-end developer. Technology agnostic, whatever the back end didn't matter. And I worked for Appintu quite a while with a lot of the jQuery core members, which was pretty cool. And I worked at home, which is great. Did some Pluralsight courses. I know many of you have done some courses, and that was great. Then I worked for Dave Ramsey. I don't know if you've heard of him, but he does a lot of financial coaching and things like that. And that was great. But I really loved working remote and at home. So I just recently joined LeanKit, which allows me to work remotely. And their offices are actually really close to where I live if I need to come in. But I like working at home. But yeah, I love JavaScript and front-end development. Particularly these days, I do React, an ES6 or 7, whatever suits my fancy, with Babel, a lot of Sass. Really, I speak at quite a few conferences. And typically the things I speak about are things that I've had pain in the past. So things I've learned, I'm like, wow, that was awful that I used to do that. And I'll try to learn something new, and then I want to share that with people. And so one of my recent talks was JavaScript Code Smells. And just things that code that works in the browser or works in Node or wherever. It's just when you look at it, it's like, this doesn't feel quite right. And more often than not, it's either maybe you haven't learned enough tooling yet to solve problems in different ways. And so it's kind of a nice exercise in thinking outside the box and figuring out maybe design patterns that might solve certain smells, and use tooling where it's possible, like linters. And if linters don't exist, then make your own rules. Just try to support and reduce the smelliness.
Awesome.
So did we already define what a code smell is?
Sort of. I tried to right there. We could actually define it.
What is a code smell and how do you smell it?
It's kind of subjective. It's just, and typically, if you're a beginner, like a complete newbie, you might think all your code is just fine. It's just as you start learning more things, you realize you need to, abstract methods and refactor and all these things. You start recognizing patterns that you're like, wow, this feels a little repetitive. Typically, like it's something that feels repetitive, but you're not sure how to pull it out yet. And typically that shows a growth in your growth curve in seniority, which is a good thing. So it's actually a really good thing to kind of sit down and think, this kind of smells, but I don't know how to fix it yet. And so, for example, like when I gave this talk, a friend of mine at work, he was actually doing a code review of someone else's code. And he pulled me aside and he was like, hey, Elijah, I think this smells, but I don't know what to do with it. And so it was a great opportunity. And I actually added a whole new point to my talk about that whole experience. And it was, essentially, he was passing data into a method, and it was returning the output of the new data. And he was passing that data into another method, and then saving it off, and passing it into another method, saving it off. And it was obviously very repetitive. And so it gave us the opportunity to let's start trying it different ways. And one, we put them in an array, and we did a for each, but we're like, we didn't quite like that because the for each had to know a little too much about the context of what data it's manipulating. So then we used a reduce and passed in the context. So internally it was building up the end result. We thought maybe that was a little too clever, or maybe not everyone would understand. And then we eventually went to Lodash and found the underscore.flow method. You could actually pass in an array of things and pass in the data, and it'll actually make sure it flows through all of them. And so it's really just an indication of, hey, this doesn't seem quite right because I'm learning more and I'm realizing it's repetitive. So how can we make this better? Now, it's obviously some of the smells I have in the talk aren't about repetition. It's just about certain things that I think are smelly. We could get into those because some of them might be somewhat controversial.
Is there an accepted repository of code smells? Is it like design patterns where there's some general kind of shared knowledge of these things are code smells, or is code smell, are they more subjective?
Now there is a list.
Let me answer that. There is a repository for.
Oh gosh, be careful what you say.
Now, Martin
really
Fowler, I think, originally defined what code smells were, and I'll have to try to find a link for all of them. But many of them, and they're not specific to any particular language. Pretty much you have too many parameters that you're passing in, and many of those code smells are about highly OOP, object-oriented programming, how you would solve some of those. And they don't necessarily map one-to-one into a dynamic language or a functional language. And so what I try to do is pick some of the common ones that Martin Fowler identified, but then pick some that are a little more specific to what we do in the front-end world.
So if I could break in here, just looked up Martin Fowler's official definition, which I really like. And I think this is going to be useful to talk about. He says, a code smell is a surface indication that usually corresponds to a deeper problem in the system. And he says, by definition, it's something that's quick to spot or sniffable, as I've recently put it. A long method is a good example of this. Just looking at the code, my nose twitches if I see more than a dozen lines of Java. The second is that smells don't always indicate a problem. Some log methods are just fine, for example. And then he goes on to talk about it. The best smells are easy to spot. Most of the time lead you to interesting problems.
Yeah, that's a great definition. And some of those real easy ones, linters like JSHint or ESLint can quickly pick up. He could do max statements that both of those support. And you could pick an arbitrary number 15. So if it looks through all your code and you have a function or a method that's above 15, then sure enough, ESLint or JSHint will give you an error or warning, which is great. Some other really common, easy ones that currently are supported in linters are max depth. So you don't want a for loop with an if and then, a while and another for. You don't want really nested code because it's harder to get your brain around all that complexity. Speaking of complexity, there's a max complexity, which is used the cyclomatic complexity score. It's been around in many languages, but JSHint and ESLint, actually, that's one of the rules now, which is great. So you could pick an arbitrary number of complexity, which really just measures all the branch logic within your code. The smaller the number, the easier it is to unit test, the easier it is to get your head around it. One of the cool ones that ESLint provides that none of the other ones provide yet is a max nested callbacks. So it prevents that, cascading of doom that you get when you have callback instead of a callback instead of a callback. So having that a really shallow number is a lot healthier code, and it just doesn't smell as bad. And so those are some really easy ones, and that I think all of us would be able to sniff those, like really long methods. But from there, I think it gets a little more complicated in figuring out what is smelly. And that's really what the rest of the talk was trying to identify, things that weren't as easy to spot.
Do you have an example? You already talked about that first one where you were kind of doing a bunch of computation on the same data.
Yeah. So another easy one to spot that there is a tool, thankfully, is just a copy paste code error, because typically what happens, and, of course, none of us would do it, but the people that we work with, right, would find some code that we wrote and it's like, oh, that solves my problem. I'll copy that and paste it over here and tweak it slightly. And if that keeps happening over and over, obviously it's a smell, but it becomes problematic in maintainability, because if there was a bug in one of those or you want to change it, you have to find all the instances. So there's two tools, jsinspect, they're both node modules, and jscpd, JavaScript copy paste detector. And both of those you can run it over your whole project, and they'll try to detect within a certain, you can actually change how many tokens it actually is trying to determine if they're the same or not. So you can make it more specific or more general. But both of those tools, and I'll provide links, are really helpful to run against your project just to kind of find those. And those would be possibly good areas to do refactoring. Hopefully you have unit tests to make sure that you're not breaking more things than you're fixing. So I ran those against our particular code base, and I was actually a little concerned when I did it because I didn't know what the result would be. But for both of them, pretty much they found the same thing. We have like transformers or adapters. Like after we do an AJAX call to our server and get the data back, we kind of manipulate it a little bit to conform to a certain object structure that the rest of our app understands. And they found some duplications in those transformers. And I was kind of okay with that because they kind of look similar, but they're very different. And so, but yeah, for your app, you could run it with your gulp system or grunt, or if you use npm scripts, have that part of your build process to kind of find those. But that's an obvious one. You're kind of asking what's a harder one to detect?
Oh, I have one question about these before you move on.
Go ahead.
How do they work with, if you're using ES6 or ES7 or Babelified code, I guess? Do they understand that, or do you have to compile your code first and then run it on the compiled code?
Yeah, so the second one, the JSCPD, does support a lot of different languages like JavaScript, TypeScript, C#, Ruby, CSS, SCSS, and HTML. And I did run it against our project, which we were using Babel, ES6 and 7. It didn't complain, and I didn't run it against the compiled result. So I guess it does.
Okay.
As far as I know, it does support it. I'll have to make sure for certain, but it does support many more languages, which is great, because oftentimes, we have the same problem in our Sass and our CSS, a bunch of duplicated things. So it might be helpful there. The cool thing about it, you can tell which languages you want to support and which file types and how many tokens, how specific or general it is. Good question.
In part of your talk, you talked about different ways that you could use ES6 to kind of eliminate some code smells. I feel like the community hasn't fully embraced ES6, so that might be a good way to talk to people to encourage them to take a look at it.
Yeah, and I try to limit myself a little bit in how I refactored some of the code, because typically in the talk I'd show some smelly code, typically code that I wrote, just because it's easier to. I'd rather poke fun of myself, or things that I've done, because I pretty much, everyone in our journey of learning has made these mistakes, and they're really, it's not mistakes, they work. It's just you want your code to smell better every time you look at it. So some of my refactors that I would show, at first I'd encourage people to have unit tests. I was like, before you refactor, you don't want to break your code. Oftentimes I would refactor using ES6. And I typically just would brush and say, you don't have to do it this way. This is just an exercise. But it didn't make many things a lot cleaner. An example of one of those, I called it the this abyss smell. And so many people, developers from beginner, mid to senior, get tripped up with this and the context and all that stuff. And so I would show like a constructor function using this, and I had a for each. And so they saved this off to that. And so they could use that inside the for loop. And I mentioned, hey, it's okay that you're saving off this is that. But more often than not, it reveals that as a developer, maybe you haven't learned other techniques yet. And so that's where we talked about bind, talked about the fat arrow in ES6, and then even some cool things that not everyone realizes, like the for each method off an array actually takes two parameters. The first one's a function. And the second parameter is actually the context you want to be used inside the first function. So you don't even have to say bind if you didn't want to. So just going through some of those exercises is kind of fun. And there's actually some really cool things in ESLint for that. There's actually a rule called consistent this. So if you want to save off this as that, you can actually tell ESLint, if I ever do that, it has to be called that or self. But one of my favorite ones is called no extra bind. It's a rule in ESLint. And that one goes to even further, where if you ever bind a function to change the context, but within that function that when it eventually gets invoked, if you never use the this implicit parameter, it will gripe at you. It's like, why did you even bind this? Because you don't even need to, because you never actually used the this implicit parameter. So ESLint's great because it's actually an AST parser, and it actually picks apart all your code into branches and figures out the execution lifecycle. So it could do some really intelligent things like that.
I also really like the section where you talked about refactoring the case statement. Would you want to talk about that?
Yeah, so that one's possibly a little controversial.
A little hard to explain to on the podcast, but...
Yeah, so particularly I suggested that just having a switch statement at all as a smell for a couple of reasons. One, the open-close principle, one of the Uncle Bob's solid principles, suggests that when you have a piece of software, it should be closed for modification, but open for extension, which when I first heard that, I'm like, those sound like great words, but I have no idea what that means. But the more and more I learned about it, it's like, oh, well, when I write some code, I probably don't want to touch it again. I want to make it so it's extendable, because if I add a new feature to it, if I actually go in and tweak existing code, the probability of it actually breaking is a lot higher. So it would be great if I could just keep old code as it is and kind of add to it later. And so with a switch statement, you're essentially going back and changing all the cases. And so you could possibly break the rest of the code. So one of the design patterns of the Gang of Four is called the strategy pattern. And typically, if you see a switch statement, you can most likely convert it to the strategy pattern. And so what I did in this particular example is I used ifs just because I didn't want to introduce the idea of native modules or CommonJS or all that. So I used an iffy. And each iffy kind of defined a particular type. And so the switch statement was like getting the area of some shape, like a triangle or a square or a circle. And so each iffy kind of just defined kind of a class of just a triangle, just a square, and had the prototype stuff. And then what I would do is if I had a new type, I would just register that type onto some like common object that has all the types that I support. And that way, if I wanted to add a new type later, I just create a new file called circle.js. It self-registers itself to the shapes object, and it just works that way instead of actually going in and modifying existing code. So I created a rule. It's a really silly rule in ESLint. Pretty much just doesn't let you use the switch statement, which is kind of overkill. So I created another rule called only simple case statements only or something like that. I'm typically okay with switch statements if it only has if in each case statement there's only one line. But what typically happens is, let's say I have a switch statement and each case has one line in it, of course with the break. What typically happens, you'll start adding more and more code into those case statements as you realize maybe it doesn't fit your needs. And that's where it gets out of hand. And so, but typically with any of these rules, JSHint and ESLint, if you have exceptions, like you're pulling in code that you didn't write and you're not ready yet to refactor that switch statement, you could disable the rule for the whole file. Or with both of those linters, you could actually put a comment, say, I want to start ignoring linting now, and then have another comment, I want to re-enable linting. So that way you could still have old code that you identify as smelly, but you're like, it's okay for now. And so, yeah, it's a little hard to describe that one online, but there are slides that you can reference to later. But essentially that's the idea, trying not to modify existing code that already works.
So one thing, since you bring up like ifs and switches and cases and stuff, that I noticed that this is something that just like makes my skin crawl, is people put like an if, and then inside of that if they check for the success condition, and then have like a huge block of code that ought to be a function, and then like else error condition, which is usually like return or exit or something, and they nest these things like 6 things deep. Right. And what you should do is do if error condition, return error code, or, reject promise or whatever. And then you never indent. And if something's getting big, it's like, if this operator is used, then replace those 50 lines with a call to a function. Else the other operator is used, replace those 50 lines with a call to a function.
Yeah, typically, like you mentioned, when you see extra nesting or really big methods, both of those are just kind of screaming like, pull me out, refactor me. And it makes your test a lot easier, our unit test a lot easier to write. It makes the code a lot easier to grok or understand. But yeah, there's many of these smells. Again, some of them are highly defined, so like the Martin Fowler list. And some of them I just tried to, like that one, I don't think there's a particular name for that smell. That would be a good one to maybe, I imagine we can make a list really long based on our experiences.
Isn't it cyclomatic complexity? Or?
Well, that encompasses lots of things.
Or nesting?
Yeah, there is a nesting one. So, but it might, if you had a pretty shallow nesting, it still might pass. But what you were saying is that like the initial return punt, it wouldn't necessarily catch that you're saying that's a good thing, but,
well, yeah, there's, what do they call it? I'm trying to remember. In my computer science class, we called it something. I think we call it the same thing in regular programming. But you want to find your base condition checking. Yeah. You want to find your base condition, which is the condition that exits you from your loop or your program cycle or your function.
Yeah, definitely. But yeah, you could possibly, it might have to be pretty smart, but you could make a custom ESLint rule to see if there's violations of that. That might be kind of interesting.
No, I think I'm just going to look over people's shoulder and nag at them.
That too.
Yeah, you'd be surprised.
Yes, then.
Jameson knows all about that.
That actually brings me to another question. So I had two questions first off, because I like to be like the voice of people who are coming in newer to programming. So the first question was like, if you ever see juniors who make like a consistent code smell. And then also, what if you're a newer program on a team and you see someone who is higher up than you writing these code smells? How do you approach that?
Yeah, the second one's a little harder, but the first one, pretty much all the basic rules that I mentioned that all the linters do exist already, like max statements, max depth, complexity. Those are the ones they're probably going to run into most frequently, or the copy paste. I see all that a lot. So you just visually, it's like, wow, these look so similar. Because we're just trained over time to not do that the longer we've been in this particular career. And so you're not sensitized as much when you're a newer developer. You're like, oh, it just works if I just copy this. So, but the reverse question, the context of this, it throws everyone for a loop. I probably get that question most when I'm helping junior to mid-level developers trying to get past that. Because the thing is, they can get most of it to work. It just might smell. But if you get the context of this wrong, things just break. So That's typically where like, hey, Elijah, can you help me? And then while I'm there, I try to kind of look around and find for other things that we could talk about. And I try to make most of my conversations just a back and forth learning experience. And that's kind of fun. But to answer your second question, the best thing that I've seen with that is just when you do for every person on the team at Dave Ramsey and for every team at LeanKit, anytime you do work, you make a pull request and at least one other person has to review it. And I think that's the best place for cross-learning, for actually juniors to look at seniors' code and not only learn from it, but to ask questions like, why did you do that? And sometimes it's like, I did that for this reason. And they're like, oh, great. But sometimes like, you noticed that I didn't use this correctly, or I could refactor that a lot easier. And so it provides them an opportunity to actually, so as a senior, we might already knew that, but like maybe we're just lazy or something like that. And maybe we didn't. So it gives an opportunity for the junior people to breathe life into the seniors, and also for them to see how we do things, and which could help them too. And even seniors reviewing, like peers reviewing peers is great too, because sometimes a system is so large, you just don't know all the stores or actions that exist or helper methods. Or even SAS mixins, like, did you know this mixin existed? No, I didn't. So it's a great time for cross-learning, for mentoring, and also helping juniors actually help things get better. So I would think that would probably be best. That's probably the least intimidating. It's still somewhat intimidating if you're a junior adding a comment on a senior. But as most of the developers that I've worked with have a pretty healthy ego, and I think the way you could kind of...
What a nice way to put it.
And I think the thing that I've seen that has worked best for seniors to lower their ego is to have a heart of a teacher and a mentor, because it constantly reminds me and whoever else where we were when we were first learning. Because once you forget that, where you were, then that's where I think the trolling and the, like, I'm better than everyone kind of sinks in. Maybe I'm wrong, but I think it helps us be grounded if we have that kind of mentor relationship with someone else. So I think it's important.
I would approach that by saying, this looks really stupid to me, so I must not understand. Can you tell me why this isn't stupid?
Yeah, and you might
That's totally the best way to do it.
And definitely it's how you approach it. Like, you don't want to be yelling at people.
This looks really dumb. Like, this is like something an idiot would do. Is this right?
Might not be the best way to approach that, but
that's how Aimee handles it. Right?
Sometimes I don't know how else to say it.
Code reviews are great, though. I've been really fortunate. I work in an environment where we do that, but I know not everyone, a lot of people I know who are juniors don't necessarily have that environment. So I was hoping to ask the question in case there were others out there who were wondering.
Yeah, I would think that if you're working at a job that doesn't have pull requests or peer reviews, maybe try to suggest it as something that they could incorporate, because it's one of the best things that I've seen, because at jobs where I didn't have it, I didn't feel pushed as much or made accountable for things as much. But as soon as that started being part of my job, it's like, oh yeah, someone's going to be looking at this. And because sometimes you just get lazy or you forget something. And as soon as someone points it out, you're like, oh yeah, I forgot. Or, oh yeah, that's a great idea. Or yeah, I think it's a very healthy thing. Do y'all mostly do that at your positions, or?
We do. And I know for me, it is like the most satisfying thing in the world when I'm reviewing someone higher up than me and I find things and I point them out. Obviously in a nice way, but it's like so satisfying.
Yeah. And it's showing that you're understanding it. Like for them, like, oh wow, she's getting it. She understands. She's tracking. Those are all very important things.
I just claim that any mistakes people find in my code, I left there intentionally to test them in the past.
Good.
You know what else too? My mentor that I've been working with, he has this like awesome insight that he said, if you have to intentionally leave something smelly for some horrible reason, you should put the reason in a comment next to the code with your initials and a date.
Yes. Doing binary OR here because a bug in Chrome V8 makes it faster in Node, which happens.
Yeah. I think Lodash does a pretty good job of, they add comments for code that's really wonky that they're doing workarounds for browsers and stuff like that. So I think that's a good use of that.
So I want to bring up something I've noticed recently. Now, I'm a proponent of isomorphic code to an extent. Like, I'm a proponent of the idea that you can write, this is the key difference, that you can write a module in such a way that it can be used both in the browser and in Node. So you're taking the algorithm that's the important part, you're abstracting that out and assuming that, you're using a typed array or an array or whatever, and that's how you're going to manage bytes if you need to manage bytes, or you pass in some function that kind of like a dependency injection style, or you're passing in the function that does the weird conversion wonky thing, and that's your module. But I've just this week come across a couple of cases where, in this past month, where people have like browser hacks in Node code because they're copy and pasting browser hacks, or people are trying to load stuff that really just deserves, to me, it seems like it deserves a second module. Like in Node, it makes sense to do it this way because you need to do 1,000 operations per second, versus in the browser, you ought to do it this way because you just need it to take up fewer bytes. Like that kind of thing. That's something I've been noticing recently, and I don't know what you call that, but when I look at code and I see that this is obviously for the browser, this is obviously for Node, but you've got 50% of your code is trying to get it to work across Browserify and Node and Require and
Yeah, it just knows too much about it. It shouldn't have to know all those things. So yeah, I don't have a good name either. Another thing that's very similar to what you're saying, but slightly different, is and it seems to be have a reoccurring thing. So like when jQuery was really big, everything you found was a jQuery plugin, even though it didn't have to be a jQuery plugin. Then if you switch to Dojo, then you're like, oh, well, I got to punt that and I have to find another one. Or now the kind of hot thing is like, oh, here's a React component. But good luck finding the underlying just library. And so I think a better way, and even back in the day, it was a better way, have a reusable, common, vanilla library, JavaScript library, and then make adapters on top of it, for jQuery or for React or for Angular 1 or versus Angular 2. And that was an exercise I also did at Ramsey Solutions with another developer, Damon Bauer, and he inherited like a jQuery plugin. I was like, hey, instead of just rewriting that, let's actually abstract the common piece of code and, use Babel or whatever you wanted, but actually have a really clean API, and then we'll make a jQuery adapter on top of it, because that's what many of the websites use jQuery for their sites. And that way we can make it's really easy to unit test the low level, vanilla JavaScript library. And then we can, once we make the adapter around it with jQuery, we can write unit tests to make sure it's passing through. Yeah. And so I really like that approach a lot better, because then, the React project we were doing for every dollar, the online budgeting tool I worked on, if we ever needed that, then we could just make a thin React component that talks to that library. Instead of have to rewrite it from scratch. And so it's sort of similar to what you're talking about, because the problems that you're mentioning knew too much about the environment. But I see that theme over and over, and I'm sure you all see it too. Like, oh, here's a Dojo specific thing, or an Ember only component, or
and Node suffers from that a lot, because people write really good code and they're like, oh, this is only going to be used in Node, and so they really heavily rely on certain Nodisms that they could abstract a couple of those functions out, and then you'd be able to use it in the browser, and it'd be great.
Yeah, definitely.
So this brought a related point to mind. It seems like part of the speed up that comes from using a framework for a while is kind of noticing that it seems like there are kind of generic JavaScript code smells, but it feels like there are also framework code smells. Like if you're a heavy Ember developer, there's probably some Ember code smells, or Angular code smells, or React code smells. Do you see those on the same level, or do you think everyone just learned the JavaScript ones and the framework specific ones will kind of come over time, or do you see a relationship between those two?
Yeah, it's you go ahead.
I just want to get a clarification. What do you mean, like a React code smell or a Angular code smell? You mean like doing regular JavaScript in the wrong way?
Smell is using state too much, using set state everywhere instead of using props more. It's kind of vague, but I don't know. They're just kind of general guidelines or things that you learn specific to the framework that seem separate from purely JavaScript specific things.
Yes, would that be like a style guide?
Yeah, maybe. But I mean, then would regular code smells be part of a style guide too? I guess we kind of talked about JSLint, so they kind of, or ESLint, so that's kind of a style guide thing too.
The nice thing about ESLint is many people from each of those frameworks have created a package of rules to try to quantify what smells might be in that language. So for example, or that framework. So for example, ESLint-plugin-react, we pull that in as well. And there are many cool things like you can actually force that you use prop types if that's something that you want to do. You could force that you add keys to things that need keys. So React could do its magic. You could actually prefer ES6 classes when you're doing React components, if that's the type of thing you like. And there's probably like 30 specific rules that are specific to that framework on best practices that your team feels is necessary. And the cool thing about it, and there's ones for Angular, there's one for Ember, one for Backbone. And so each of those particularly like, hey, you should use mixed services or whatever the thing is in that particular framework. But the cool thing is if there's more that you find appropriate for your stuff, you can either contribute to those repos or make your own set. But yeah, that's a great question. And we do use the React ones against our projects because they are quite nice.
It seems like in some ways CodeSmell is a fancy word for experience, because there's not this like defined list of 20 code smells and nothing else is a code smell. It's just like you learn enough to see when something can go bad later on. How do you get better at identifying new code smells?
Yeah, that's a great question, because like some of the ones, so the talk that Aimee saw was really short, but normally like an hour or just a little bit longer talk. So there are things I talked about in the longer version that are kind of just experience. Like one I called the incessant interaction smell. And it's a little less JavaScript, but it's more just like from a UI standpoint. Like think of an autocomplete box, for example. When you're typing in, you don't want each keystroke to actually make a call to the backend server, because your backend friends would not like you. And you could DOS yourself, which would not be good. And so like the first thing to think about, like, oh, I should throttle this, or at least have a min number of characters. But even throttling doesn't quite do what you probably would want it to do. Because what throttle does is typically in like Lodash or underscore have a throttle, or Ben Allman has a version he wrote a while back. But what throttle does, you give it some interval, like hey, every 500 milliseconds, or only want to make one call at every 500 milliseconds, at least, or at the most, I guess. But what could happen, someone would be typing and typing and typing, and not just really quickly, and it could be making several calls, but from a UX standpoint, that's still probably too much, because they haven't really even paused to take a breath or even think about what they just typed. Probably you want to autocomplete when they've kind of stopped for a half a second or 250 milliseconds. And so I still call that a smell. I'm like, there's something called debounce, and for a long time I never knew what debounce meant. But again, __ have it. And it's the same API as throttle. But what it means is if I say debounce, wrap in my function with a number, that means you have to wait until that event at least stops for that long. So I could be typing, backspace, type, and then pause for a half a second. And that's when one call goes out to the server. And so I call that a smell. It's maybe more of a UX smell, but it's really how you solve it with JavaScript. So I kind of added it in there. But that could be really handy for like autosave. So for example, I worked on a project for a company where it was kind of like a WYSIWYG type email editor. And every like maybe 15 seconds of non-activity of certain events, we would just autosave a version that they were working on. And so debounce was really handy for that. So that's a particular one that was more from experience, like you just mentioned. It wasn't like a hard set rule, like you should always do it this way. But yeah, just over time, when I learn something and want to tuck it away and realize maybe not everyone else knows that, then those are the things I like to share. Like, hey, I made a mistake, or I did this and it was painful. Here's a better way.
So one of the things that I'd like to talk about, we briefly touched on this when we talked about the definition of code smells, is code smells where it turns out you don't want to make a change, don't want to fix. It's actually not a problem. How do you go about identifying those and deciding, even though this looks wrong, it's actually okay, I'm going to leave it the way it is?
Yeah, that's a good question too. And I guess part of the answer depends on if your rules are triggered against it. And if it is, then that's where I just put comments. I just disable that rule for a particular block. Early on, before I was using ESLint, JSHint would complain about a lot of the ES6 and ES7 stuff we were using. So we regularly had to tell it to ignore certain chunks of code. And I'm trying to remember, I think it was when we were doing REST and spread and destructuring, some of those, they got confused. But since it's gotten a lot smarter. And so in that case, we actually didn't think it was smelly. It was just the tools we were working against. If it was really something that we felt was smelly, but our tools didn't catch it, probably wouldn't worry about it too much. I don't even think it would deserve a comment. If it got through all the pull request reviews and we felt good about it, I typically don't like to put extra comments for things I don't feel are extremely necessary. I don't know. I guess it would depend partially on what that smell is. Do you have an example, or it's just more of a high level discussion?
Well, say that you have a method that takes in 8 parameters, which is a lot of parameters.
Gotcha.
You look at it and you decide, I could break this down, but it just doesn't feel right to break it down. This just makes more sense to leave it. Or, maybe you've got a method that has extreme number of lines of code in it. You just feel like, it's okay the way it is.
In those cases, I would have rules for all those, and then I would put a comment to ignore it. And then that would be indication for whoever, either one, it's okay, or two, maybe someone else in a future point could actually go in and refactor it if they wanted to. Or maybe because you'd have to disable it either way. Maybe disable it and add a comment like, "This is okay. You should not refactor this," because maybe there's a hard dependency. You're integrating with another library that has to have specific parameters or something like that, or it's receiving those parameters, and you don't have control over that. That would be an appropriate place to say, "This is like this for a reason. Don't refactor it." The signature is important. But yeah, above that, I'm not really sure. Or maybe you could write, if you use a JSDoc or something like that, list out all the parameters and say it's actually a good reason, like this maps to another library or something like that.
Right.
So here's a question I have related to that. Why use parameters at all? Why not just always pass in a single object? I mean, this is just something I've thought about recently.
Oh, definitely. That's usually what I say when I give the talk, because the first smell I do is just some really nasty code I wrote 6 years ago in a blog post. And so I was passing tons of parameters. I'm like, hey, if you could say If it's over 4 or 5 parameters, maybe you should pass in an object instead. But to the point we said earlier, maybe there's some integration that it has to have that signature for it to work, and you don't have control over how it's being called. But generally, I think objects are much nicer because they're a little more self-describing, because once you get a really long signature and you're trying to invoke that signature, it gets really hard to tell what parameter is what.
Well, and you can't pass it to a promise. There's other areas where it just...
Yeah. So overall, I would typically prefer an object.
Although, if you're looking at like code that's very hot code, that object thing could come back to bite you because that's memory allocation that's got to be garbage collected.
Oh,
depending on how you're passing the object and whether you're mutating or you're copying rather than mutating.
Yeah, and some of that you just have to figure out as you run it and as you exercise and profile it. But an interesting one I brought up, and I don't always agree with it because it could go both ways, is anonymous functions. So like passing a callback and not giving it a name. That could be problematic because if you ever do profiling, like we just mentioned, like maybe you do have code, like you mentioned, that has a leak or just very memory intensive. If you use lots of anonymous functions when you pass in like callbacks, then when you do stack traces or profiling, you'll see all these anonymous. And it's really hard to figure out which the one that you really want to actually figure out how long it took and where the memory is being taken. Mm-hmm. And so by just like you could still pass in an anonymous function, but then give it a name, which obviously is not anonymous anymore. But that way, when you do a profile or stack trace, you actually map it to a particular name, which is really nice. And naming a function like that allows you to dereference it. So if you've ever wired up like a subscribe on an event bus or an event listener, if you actually give it a name, then inside of it, you could remove the event listener or you could remove the subscribe. So it's like a one-time only. So like if I click on something, it could only fire one time and never click again. So there's some good reasons in code reuse. Obviously, if you name all your functions, you could reuse them easier. But one of the downsides is, the fat arrow, which everyone likes. If you use that, it doesn't have a name. And I don't think you can't name that as far as I know. Can you?
Not that I know of.
Yeah. So that would still be anonymous. But so when people ask me about that, I was like, I don't necessarily name all of mine, but if I know I want to dereference or have a nice stack trace or a nice profiling, then I'll give it a name just because. And that's more wishy-washy. Like some of the ones I gave, very subjective, but just think to be aware of that they could bite you down the road. And some of that's experience, like you all mentioned before. But
right. Cool. Do we have any more questions before we wrap up? Is everybody pretty much
smelled out?
All right. Well, let's move on to picks then.
Before we get to picks, I want to take some time to thank our silver sponsors. This episode is sponsored by Thinkful.com. Thinkful.com is the largest community of students and mentors. They offer one-on-one mentoring, live workshops, and expert career advice. If you're looking to build a career in front-end, back-end, or full-stack development, then go check them out at Thinkful.com. This episode is sponsored by Track.js. Let's face it, errors cost you money, you lose customers, server resources, and time to them. Wouldn't it be nice if someone told you how and when they happen so you could fix them before they cost you big time? You may have this on your back-end application code, but what about your front-end JavaScript? It's time to check out Track.js. It tracks errors and usage and helps you find bugs before your customers even report them. Go check them out at trackjs.com/jsjabber.
AJ, how about you? You want to start us off?
Sure. There's a film that's done in cooperation with Mozilla and the Electronic Frontier Foundation, I believe, are two of the sponsors, called Terms and Conditions May Apply. And it's an interesting documentary kind of detailing privacy and legal considerations about what happens when you click I agree. It's a little bit scary, honestly. And one of the funny facts that they mention, or perhaps not funny, but I thought it was kind of hilarious, is that if you were to actually read every agreement that you click I agree for during the course of a year, it would be 180 hours or a full work month of reading user agreements.
Wow, that's a lot.
And I will pick also not spending 50% of your code trying to make it isomorphic by detecting which environment it's running in, because you will lose. And then there's problems, and it sucks. And I don't want to deal with that.
Cool. Aimee, how about you?
Okay, so I had Nodevember before. I'll call it a pre-pick. I'm going to pick it again as a post-pick because I feel like I've been really spoiled. I've gone to some awesome conferences, going to NGConf and Angular Connect, but Nodevember was great too. It was just like a really, really, really genuine vibe. There were great talks, all around a great weekend. So if you have the opportunity to go next year and they have it again, you should totally go. And of course, Nashville is amazing. And then my second pick, I've listened to a ton of podcasts, and some of them I'll skip around episodes because I only have so much time in the day. But I found a new podcast that I actually have not found an episode yet that I don't like, and it's called Developer Tea. They're just kind of like 20-minute, very short episodes, but they're all very, very practical. So I would encourage people to check that out. And that is it for me.
I'm going to start off by picking a ukulele player. Apparently, it's not a ukulele, it's an ukulele. And that's what they said when I went to Hawaii. But there's this ukulele artist named Jake Shimabukuro. I think he's Hawaiian Japanese, and he is amazing. I've absolutely enjoyed everything that I've listened to of his. So if you're looking for some really awesome, very enjoyable music to listen to, I highly recommend what he's got. Check him out on Spotify. Very good. And then for my second and final pick, I'm going to pick Screeps.com, which is a massively multiplayer online game where you have to code to play. You don't actually play the game, you code up in JavaScript how your guys will play, and that's how you play the game. And it's super awesome, and if you are learning JavaScript, it's a great way to kind of force yourself to learn JavaScript, very interactive. And I've only played around with it for a little bit, but I've really liked everything that I've seen. It's well documented, very interesting. So that's my second pick. Elijah, how about you?
Yes, I have two. They're related. So when I worked at Ramsey Solutions on the project we were working on, it was React, and we had a component library or like a living style guide, but then it was actually written in handlebars and like a totally different technology than the rest of our app. And so over time, it got out of date, and we started there, and then we pulled over the markup into React component. But from then on, we just developed the React component, and it just, the style guide kind of died over time, which kind of stunk. And so, I was on the lookout for a way to kind of kick that off again, but actually use the real React components that we were building, because that way they wouldn't get out of sync. And so there is this project called react-styleguide-generator. And what you do is you create a component, and then you wrap the real component that is in your system. And then you give it some metadata, and it will generate this nice style guide for you based off the real things that you're using. And there's another one called react-styleguidist. I haven't played with that one yet, but when I tweeted the previous one, someone mentioned like, hey, here's one that might be cool too. So I definitely want to look in both of those for my current job at LeanKit, because they're wanting to create a style guide as well, and they didn't have it yet. So I'm going to be digging into those. And I think it's a smart thing to have, because at Ramsey Solutions, on other projects I was on, we had style guides, and it was really helpful for the designers and the UX people to have a common language of what's available. And when we got comps of things to change, like we could go like, hey, that looks different than our style guide. Was that on purpose, or can we actually use something that we have before? And it was a nice conversation piece. And also was helpful for the developers to know, what classes should be used when. And so, yeah, I think it's great. And hopefully they will be helpful to others as well.
So can I add one more? I forgot to mention this, but I meant to. I've watched a lot of Star Wars rewrites for episodes 1, 2, and 3, because they obviously need to be rewritten and hopefully one day redone properly. But the best one that I've found so far is called The Phantom Menace, What It Should Have Been, and Attack of the Clones, What It Should Have Been. And I've got the YouTube links there.
Cool.
How long are they?
The first one is about 40 minutes, and the next one's about an hour and a half. So they're feature length, but they're done with stills and backgrounds. And then there's supposed to be one that's coming out for Revenge of the Sith, What It Should Have Been. But I mean, they're complete rewrites from the ground up. There's hardly any similarities other than that there's an Anakin and there's an Obi-Wan and there's a Phantom Menace.
Wow. That sounds pretty cool.
That's awesome. Definitely going to check that out. All right. Well, thanks everybody for listening in. We're happy to have you as our listeners. Gosh, audience.
Yes.
That's the word I'm looking for. Audience. Oh my gosh.
Listeners.
We do this, of course, for the audience, so thanks for listening in, and thanks to Elijah for coming on and being our guest this week.
It's been an honor
Engaged
to hear.
conversation. Yeah.
Thank
Yeah,
you.
honor for us as well. And we will look forward to seeing all of the audience next week, although we won't actually see you, but we'll look forward to you hearing our luscious voices.
Yeah.
And guys, if you just go on GitHub and like star me, it makes me feel so good. So, or just check out my Twitter and retweet me. You know, just.
But if you do go on and star AJ, please pick something completely innocuous and ridiculous. A repository he's likely to delete within a week. All right. Well, again, thanks everybody, and we will see you all later.
Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more. Do you wish you could be part of the discussion on JavaScript Jabber? Do you have a burning question for one of our guests? Now you can join the action at our membership forum. You can sign up at javascriptjabber.com/jabber, and there you can join discussions with the regular panelists and our guests.